Kia ora Year 11 and 12. In this video we're going to look at how to find the distance between 2 points. So I'm going to start by labelling my points. We'll call this one A and this one B. Now A has got coordinates 3, 2 and B has got coordinates 9, 10. You can check that for yourself by counting out along here for the x coordinates, right, the first number in each pair, and the same thing for the y coordinates. So we want to find the distance from A to B. We're going to use Pythagoras theorem to do that. So we'll drop a vertical line down here from B. We'll go down as far as the horizontal coordinate with A. So we've now got ourselves a lovely right angle triangle. So let's have a look at what we can do with that. Well, we know that this distance from A to point C, we'll call this one point C, is equal to 1, 2, 3, 4, 5, 6 units. And we know that this distance is equal to 8 units. So if we label this length here x, no, that's a really bad choice of letter. Let's not label it x. Let's just leave it as length AB for now. Well, we know that that distance squared from Pythagoras must be 6 squared plus 8 squared. And that equals 36 plus 64, which is 100. So to find length AB, it's going to be the square root of 100, which is 10 units. Okay, so that's the idea of how we find the distance between 2 points. We're going to turn that into a formula, but really you don't need to draw the formula as long as you've got a good sketch and you've got a right angle triangle set up. I've got 2 more problems for you to try on the next 2 slides. I want you to pause the video and have a go at them before I work through each one. Okay, so here's the second one. Pause it and have a crack at it. Now, this is point A and this is point B. So A has coordinates 4, 2 and B has coordinates 11, 6. Join the points up. Draw in our right angle triangle. So this time we're going to use the values instead of counting to work out the distances. So 11 minus 4 is equal to 7. That's my horizontal distance, AC. Next, looking at the vertical distance, it's going to be 6 minus 2, which is 4. So, length AB squared is equal to 7 squared plus 4 squared. That equals 49 plus 16, which is 65. To find the length AB, I need to take the square root of that number. So it's the square root of 65, which is 8.06 units. And that's to 2 dp. Okay, one last one. I'm joining point A to point B. So I'm going to have a slightly different looking right angle triangle this time. So A has coordinates 4, 2 and B has coordinates 11, negative 6. So let's think about what I'm doing to get my final answer. So we're now going to turn what we've been doing into a formula. So the distance is going to be the square root of the horizontal distance squared plus the vertical distance squared. So let's join up A and B. There they are. Draw in our right angled triangle. What's my horizontal distance? Well, it's the difference in the x values squared. And we're going to write that as x2 minus x1 squared plus the difference between the 2 vertical coordinates. So So that's going to be y2 minus y1 squared. It's one very messy square root sign. So that's my formula. So what we're doing here is we're starting to get a little bit more formal with our notation. So we'll call point A the point with coordinates x1 and y1, and point B x2, y2. So in this case, what have we got for length AB? Well, it's going to be 11 take away 4 squared plus -6. Oops, where's my pen gone? There we are. Sorry about that. -6 minus 2 squared. So that gives me the square root of 7 squared plus -8 squared, which is the square root of 49 plus 64, or root 113. And that gives me a final answer of 10.63 units. Okay, so that's the basic idea of how to find the distance between 2 points. It is worth getting used to using that formula and identifying the coordinates here. Okay, thanks for watching, and I'll tell you in class which Walker and theta exercises to follow up with.